This A-level maths question separated those students who really understood the subject from those who did not. Only the very best students were able to score full marks. Would you be amongst them? The examiner said that this question discriminated well between candidates of all abilities, with only a few candidates gaining full marks. Let's have a look at it and see why so many students struggled. It says the figure shows a sketch of the curve y equals g of x, where g of x depends on the value of x. If x is less than or equal to 2, then we have this equation, so that's that part of the curve. Whereas if x is greater than 2, then g of x is actually just a straight line, y equals 4x minus 7. In part A, it says find the value of g of 0. What does that mean? Well, it means find g of 0, and then substitute that into g. This is called a composite function. So first of all, let's work out what g of 0 is. Which of these two parts would I use? Well, we're working out g of 0, and 0, is that less than or equal to 2 or greater than 2? It's less than or equal to 2. So we're using this part of the equation. So we're just going to replace the x here with 0. If we do the number crunching on all of this, minus 2 squared is 4, plus 1 gives you 5. So now we're working out g of 5. Do I use this again? No, because 5 isn't less than or equal to 2. 5 is greater than 2. So I need to use this part of the equation now, this branch. So we do 4 times x, which is 5, minus 7. 20 minus 7 gives you 13 for the second mark. Part B said, find all the values of x for which g of x is greater than 28 for 4 marks. So let's think about this. We've really got two graphs hiding here. We've got the graph on the left here. That's the curve that we've got here defined by these two parts. And we've also got 28, y equals 28. What does y equals 28 look like? Well, you should know that that looks like a straight line, a horizontal line like this, through 28 on the y-axis. So we're looking for the values of x for which the y value of g of x, the y value of the curve here, is greater than the y value of this horizontal line, greater than 28. Where would that be? Where is the curve higher than the line? Well, here and here. Now, notice that g of x is a piecewise function. It's really two functions that are glued together. We've got this quadratic part here on the left. That's when x is less than or equal to 2. So here would be where we find 2. That's our quadratic graph. And then we've got our straight line, y equals 4x minus 7, to the right of 2, for values of x greater than 2. So we're going to try to find out what are these key points, these critical values, when the quadratic part of the graph equals 28, and when the linear part, the straight line part of the graph, also equals 28. So let's split this into two cases. Let's start by considering the quadratic part of the graph, for which x is less than or equal to 2, so this part of the graph. When x is less than or equal to 2, g of x, this part, would be the quadratic. And we're just going to set that equal to 28, just to find out when they're equal. If we subtract 1 from both sides, we end up with 27. To get rid of this square, we take square roots of both sides, but we mustn't forget plus or minus signs when we do that. We can split up the square root of 27, because 27 is 9 times 3, like so root 9 times root 3, and the square root of 9 is 3. So we've got 3 root 3 for the square root of 27. Next, we can add 2 to both sides to get rid of this minus 2. So we end up with two possible values. But remember, x is less than or equal to 2. So the one with the plus would be too big. 2 plus 3 root 3 would be bigger than 2, not smaller than 2. So we need to reject that plus value and only consider the negative here. If you get that far, you get 2 marks. Now, notice we want that the y value of the curve here to be greater than the y value 28. And that's happening in this section of the curve. That corresponds to this x value here, which is 2 minus 2 root 3. So overall here we have x is less than 2 minus 2 root 3. Notice it's not less than or equal to, because in the question here we have a strict inequality. So it's got a match there. What about the other case? What about the other branch? Well, that's when we have the straight line, y equals 4x minus 7. Let's find out when that intersects with y equals 28. Let's find out the critical value when they're equal. So if we solve this equation, we end up with x equals 35 over 4, but we're looking for the value of x for which g of x is greater than 28, not equal to 28. So that's going to happen in this section here, corresponding to this section here on the x-axis, which is where x is greater than 35 over 4. So overall, we've got two separate regions. We've got x is greater than 35 over 4, and then a separate region here, x is less than 2 minus 2 root 3. Now, because they're two separate regions, we can't combine those together into a single inequality. So when we give our final answer, we want to say overall, well, x is either this, comma, or this. You can just separate them with a comma in this question. Part C. It says the function h is defined by this equation for x is less than or equal to 2. So notice that this is very similar to what we had here, except it's only this part. So if we imagine the graph of h of x, it would just be this part here. It wouldn't include this straight line part. So what's different about h of x and g of x? Can you explain why h has an inverse, but g does not? Well, h is what we call a one-to-one function. Notice that for each output here, each y value corresponds to a single input, a unique input. And that's going to happen for any value on the curve. Each y value here corresponds to a unique x value. And that means that it's a one-to-one function. And one-to-one functions have inverses. So that's why h has an inverse, because it's one-to-one. Why doesn't g have an inverse? Well, remember, g of x is this entire graph. Notice that for g, if I take a y value, say here, well, there's not just one input x that corresponds to that y value. In fact, you can see here, for example, there's more than one. So this function here is a many-to-one function, and many-to-one functions don't have inverses. So that's what they were looking for you to say for 1 mark. Part D asks us to solve this equation. This is the inverse of h, not the reciprocal, don't get those confused. Not 1 over h of x here, this is standing for the inverse function. So the inverse equals minus a half. How can we solve this equation? Well, if we apply the function h to both sides, so if I take what we've got here, and we apply h to it, so start with this and then apply h to both sides, then something really special is going to happen on the left-hand side. Because what we're doing here is we're applying the function to its inverse. Those two things are going to cancel one another out. Because the function is undone by its inverse. They're like opposites. It's a bit like adding 3 and subtracting 3. Those two things cancel one another out. Or multiplying by 5 and dividing by 5. They cancel. So by doing that, these are going to cancel, and what I'm left with is just x. So x is h of minus a half. So all we have to do is go to our function h here, and just replace each x here with minus a half. So replacing that in the function, we get this. If you do the number crunching on this part, that's minus 5 over 2. Square it, we get 25 over 4, and do the number crunching, you get 29 over 4. That's so much easier than trying to find an equation for the inverse, which many students try to do in their exam, and they got a bit confused about what to do about plus or minus signs when they take square roots. Doing that, this method, though if you've never seen it before, might seem a bit confusing at first, but actually for this question, it is so much quicker and easier. Do you think that you would have been one of the very few students who scored full marks in this question? Let me know what you think made this question so tricky. Let me know in the comments.